Record, and now I am going to share my screen with you, lovelies. Bam. You go down the bottom, come up the top. And again, I do believe all of you have enrolled in the class, but if you haven't, here is the class enrollment code. Write it down somewhere so that you will be able to join the class and do the assignments, one being overdue at this point, checkpoint 1, which I'm hoping, again, most of you will have it done by the end of this week. All right, so when we talked about this course, I told you that we will be studying various graphs. So that, and we are calling it the broad topic, representing data. And our objective is to create a graphic representation of data, and again, just to create a graph. The state of Pennsylvania says that we have to make sure that we cover certain topics. So for this, the standard says that we are going to use or apply quantitative reasoning to choose and interpret units and scales in formulas, graphs, and data displays. Ultimately, you are going to be able to look at a graph and interpret the data, or look at data and create either a formula, a graph, or some data display of that given data using the proper units. So our agenda, as usual, we will always have a community meeting just to talk and, get to know each other on another level. We'll review what the two representations we've already discussed, which are dot plots and histograms. We are going to do a lesson on box plots, because box plots seems to be the sticking point for most people. And then there is a practice. And just as a preview, the assignment that will be due next Friday will be the second cool down. So let's get it. Okay, so let's start our review. So we talked about a dot plot. And again, dot plots are used on small data sets. It shows the individual terms in a set, and each dot represents a term. And the height of each bar represents the frequency of that value or category, or how often does that thing happen. So our good morning. So our dot plot is about the number of brothers and sisters. So, looking at this graph, we can have specific conversations about this data. So we can say that there are 2 only children in this set. We can say, what else? Anybody else got something from this graph? What can this graph tell us? Again, we have 2 only children. What else? And part of the course is also about interpreting data from a graph. So I'm gonna need some, some give and take, good people, some give and take. All right, but that's okay. I'm gonna let y'all live this time. So from this graph, we can make comparisons. We can say those people who have 1 sibling and those people who have 3 siblings are the same. Because again, we can see the terms. Most people have 2 siblings. And if we had to go from the graph to the actual data set, we understand we would have 2 zeros in our data set. We would have 3 1s, 5 2s, 3 3s, and 2 4s. So again, a dot plot is good if you want to see individual terms, because you can talk about the individual members of this set. And again, ladies and gentlemen, remember, just like if we were in school, face to face, you need to be taking some notes. You will have, remember, your notes are going to serve as your notebook. You know, at the end of the term, your final is open book, open notes.
When the
So
term ends.
the term ends on January the 22nd.
All right, say no more.
Okay. So again, make sure you take notes. Make sure your notes are in the language that you understand so that when you look back at them, they will make sense. Okay. You write down what you need. Don't worry about what somebody else needs. All right. So we are good on the dot plots. Everybody has whatever notes they are going to take.
Yeah.
Okay. I was going to say your silence means consent. All right. And then we talked about a histogram. A histogram is based on continuous data. So as a result, there are no gaps between the bars. Now, there may be absences, but there are no gaps. And the data is organized in a frequency table that is divided into bins. And the bins are just equally spaced groups. So when we look at the histogram that is here, again, just by the way the histogram is numbered, we see that it is continuous. There is no break. The end of one, excuse me, the end of one bin is the beginning of the next. And remember, when we are placing terms into bins, the high end gets counted in the next group. So that means these, let's say 4 people, their heights are between 120 centimeters and 139 centimeters. In the second bar, those students are between 140 centimeters tall and 159. So the high man gets counted in the next group. And when we compare a histogram to a dot plot, the difference is we don't actually know about the individual terms in a histogram because we've grouped them together. So therefore, in this 15 people or 15 students who are between 200 centimeters tall and 219 centimeters tall, all we know is that there are 15 people in here. We don't know if they are 210 centimeters, how many are 215 centimeters, how many are 211 centimeters. We don't know. All we know is between 200 centimeters and 219 centimeters, there are 15 students. Whereas if we use the dot plot, which would of course be a little different, a little tedious in this instance, because one, the data set is large, because we can see in the first 3 towers alone, 24, about 24, 34, about 38 in these first 3 towers. So if we were to use a dot plot, how long would that line be? Okay, how long would it be? Because we would have to have something from 120 to 240. So first of all, the line itself would be long. Okay, so that's why, again, in this amount of data, it is best to use a histogram. And again, it is continuous, so there are no spaces between the bars, and each bin or each tower is equidistant. So we see, again, 120 to 140, that's a 20 spread. Each is a 20 spread. However, remember, you only count in that bin up to the number before the end. Okay? So, write what notes you need to on histograms. because again, we will be using them. Okay, the seniors are still typing me, or the graduates. Can we move?
Hold on, Mrs. I'm still writing it down.
Okay, that's why I asked the question. Thank you, dear. I'm trying to find the link
Shut up, Nate.
to the celebration for today, so that I can send it to my babies.
Or you could go on and say my foot filling you up.
You not holding me up, girl. And you know you can always come to the lab.
Yeah, I got work.
Oh. What? Wait a minute. I'm trying to send the students, the November grads. I'm trying to send them the link to today, to the celebration. It's about them. Oh, come on. I don't even know where it is. All right, so we ready?
Yeah.
Okay. Now we're going to talk about a box plot. When you were in middle school, you probably called this a box and whiskers. But a box plot is a 5-number summary of the data. So, you know, when we are talking about statistics, you know, we discuss the mean, mode, and median. So, just like any other time when we are thinking from a statistical standpoint, we're going to first put the data in numerical order. Steps 2 through 5 will then help you with the 5-number summary. So in number 2, you identify the maximum and minimum terms of the data set. So that's 2 of the 5. In step 3, you find the median or the Q2 of the data. So now, let's take a step back. When we just look at the structure of a box plot, it is divided into 4 parts. So just like if we look at a box plot as $1, this is the first quarter. This is the end of quarter 1, quartile 1. This is the second quarter. The median is the end or Q2. This is the third. This is the next quarter. And this will be Q3. And this is the fourth quarter. And that is your other whisker leading you to the maximum value. So the Q's just mean quarter. First quarter, second quarter, third quarter, fourth quarter. In math, they are called quartiles. So quartile 1, quartile 2, quartile 3, quartile 4. Okay, these are the 4 parts. So we have found so far the minimum and the maximum. So that's 2. In step 3, we find the median of the entire data set. So now, remember, the median splits the data in half. Okay? So that is the middle of the data set. And then we find the median of the lower end of the data, and that's Q1. We find the median of the upper end of the data, that is Q3. So those are the 5 numbers that will be in the summary. Let me end this for a second. So now we have the maximum 1, the minimum 2, the median of the data set, that's 3. The median of the lower half of the data, that's 4. And the median of the upper portion of the data. So again, a box plot is a 5-number summary. So maximum, minimum, the median of the data set. Oh, I don't know why this one didn't go. The median of the lower half. I don't know why this one didn't change. Oh, I see. Okay. Damn. Okay, so those are the 5 numbers. The maximum and the maximum term, the minimum term. The median of the entire data set. And because the median splits the data in half, then you will find the median of the lower half, and then you will find the median of the second half of the data. And those will be the 5 numbers that you use in your summary. So just because we are running out of time, and I want to at least get this piece in, I am going to show you, if we use the data set at the bottom of the screen, 9, 7, 2, 5, 12, 14, 16, 13, 18, here is what it would look like. So the first step says to put the data set in numerical order. So here, the data set is in numerical order. Here is again, starting from steps 2 through 5, we find the 5-number summary. We have the minimum value, which is 2. The maximum value is 18. So 2 and 18. we have 9 numbers in the data set. So the median, we come 4 in from the left, 4 in from the right. 12 is the median. So we have now split the data in half. So for Q1, for Q1, we only want to look at the front half of this data. Okay? So now we are at step 4. We only want to look at this portion of the data because, again, step 4 says that we want to take the median of the lower half of the data. So this is the lower half of the data. So now we know that the median is the middle. But when you have an even number of terms, there is no physical middle. So does anybody remember, if we have an even number of terms, how do we find the median? Somebody talk to me. How do you find the median of an even number of terms?
Hey, what you say?
How do you find the median when you have an even number of terms? Anybody remember?
Don't you got to add both of the middle part together?
Yep. And then do what?
Divide. Right?
Divide by 2, right?
Yes. So to find, again, we are on this first half of the data. So we are going to use, it's an even number. We are going to use these 2. And here we will add 5 plus 7. And then we are going to, we're going to try that again. Here we go. And we're going to divide by 2. So therefore, we now, 5 plus 2 is 7. 5 plus 7 is 12, excuse me. And 12 divided by 2 is 6. So if we were in class, I would tell you, you draw a little arrow up here and put a 6, because that shows you it is the middle of the first half. And then we would do the same thing for the second half of the data, which I am now going to put back. Okay, so now when we just looking at the second part of the data, or the upper end of the data, we would do the same thing. So again, we are only talking about 13, 14, 16, and 18, because 12 split the data in half. And same thing as Quay and Amai said for Q1, we have 4 terms. We will add the middle 2. Okay, we will add the middle 2 and divide by 2. So 14 plus 16 gave 30. 30 divided by 2 gave 15. And again, in your data set, you put a little arrow up here and put 15. So now you have the 5 numbers that go into your, excuse me, that go into your box plot. The minimum goes first. the maximum goes last. So we see where our data begins and where our data ends. And then we put in our median, which is the middle of the data, 12. We put in our measure of, I want to take this space out of here just so that the answers will move up. Okay. Thank you for your patience. We have our, again, 5 numbers. So here's our median of the entire data set. The median of the first half of the data, or the lower end of the data. And then this is the median of the upper end of the data. And you will see with the placement, the median would be closer to the median of the upper half than it is to the median of the lower half. Because the median of the lower half is 6. 6 is 6 away from 12 versus the median of the upper half, which is only 3 away. And the structure matters, and we will see once we start comparing the graphs. Okay, we will see why instead of putting this median directly in the middle, we put it closer to the right side. We put it closer to the median of the upper end of the data. Okay, so again, the structure, minimum value, the middle of the lower end, the middle of the data itself, the middle of the upper end, and the highest term of the data set. And there you have the 5-number summary. And again, you can have some conversations about how this data is presented this way. Okay, once again, we don't necessarily know the individual terms when we just look at the graph. We just know the lowest value is 2, the highest value is 18. So we know that there is a range of 16, right? 18 minus 2. We don't know, we know that the middle of the data set is closer to the middle of the upper end versus the lower end. So that tells us something about the shape of the distribution. Remember, we talked about that? I told y'all it all comes together. And we will pull that piece in. So that's why I say take notes, ladies and gentlemen. It all comes together. So we are going to, because we have about 6 minutes. So I want you all to get, make sure you get the notes on the dot plot, because our warm-up, where we're going to start on Tuesday, we are going to do a box plot and a histogram of the same data set, because that is going to lead us into our conversation about comparisons of data. Of data representations. Gotta write myself some notes. So I take notes too, y'all. I have a notebook too.
Bruh.
Absolutely. First of all, you know I do the problems by hand. So when I give you all, like when we do the exercise sets, I do the problems myself first. Because 1, I need to make sure that I understand how to explain the problem to you. And then when I'm doing the problem, I also think about what problems might you all have, so that again, if it comes up, I'll have an answer, or I'll have maybe, I'll do it one way. And you may say, well, I got that answer, but I did it this way. Helps me. Again, I learn from you, you learn from me. But yeah, so I do the
Okay,
problems
it's smart.
myself. Yes.
It's smart.
Listen, and plus y'all know I don't have no life. So I sit home and I do math problems. Or I think about, should I give them this one? Should I give them that one? Well, this one we're going to do together, and maybe I'll give them this one independently. So, as a teacher, your job is never really done. You might not have students, but you're constantly thinking about how can I present this? How can I make this, a little simpler or a little more plain so that you're like, oh, okay, all right, I get it. Okay, so we shall, do what we do. But again, I implore you, somewhere in your notes, I want you to write down these 5 steps so that you will have a guide when you have to do it by yourself. Okay? And remember, 5 number summary. So those are the things in your directions that you should underline. So those are the 5 numbers that go in the summary. Your maximum, your minimum, the median of the entire data set, the median of the low end, and the median of the high end. And all I ask is, once you find all of those numbers and you do your box, because the box is what your medians create your box. I would like you to place the median closer to whichever quartile it is closest to. Now, if it's equidistant from both, you could put it in the middle. But if it's closer to the median of the low end, if Q2 is closer to Q1, put it down there. So if it was 8 for our sample, it would be down here somewhere. It would be closer to 6. If it was, let's say, that's 9. Yeah, it's not. I was trying to see if it was even, but the distance, the interquartile range from 6 to 15 is 9. So I can't even say, well, so if I add 9.5, or if I add 4.5, so let's say if it was 10.5, if 10.5 was the median, then I would have put it in the middle, because 10.5 is 4.5 this way. No, it still wouldn't work. So I would have it, yeah. So all I'm saying is, place the medians close to whichever end. I was trying to make it work, y'all. I was trying. I wasn't too quick on my feet. All right, so ladies and gents, it is time for us to join the senior celebration, which starts at 11:30. So as soon as you get these notes, I would like you all to so good, people.
So is we going over there now?
Yes.
We gotta go, Miss Six.
We are going to we're going to do a little celebration of the 2020 grads. I mean, the November grads. I'm sorry. So we're going to jump over there, and we are going to, like I said, celebrate them for a little bit, and then we will have a good day.
Someone got a link to that joint.
Wait a minute.